In this lesson, we're going to look at translating verbal expressions into mathematical expressions, equations. Now, in this lesson, we're going to be focusing mainly on these types of problems. So, sometimes we call these problems number problems or consecutive integer problems. Consecutive integer problems. All right. So, so let's look at number one. So, number one, you have one number is four more than three times another number. And if the sum of the numbers is 88, what are the numbers? All right, so remember in our procedure for solving word problems, so you identify the problems, you read the problem one time and note what you're asked to find, then you make any notes, then you assign a variable, set up an equation, solve the equation, and then check to make sure it makes sense. So, so let's read this again. So one number is four more than three times another number, and then you're told that the sum of the numbers is 88. So you have two sentences here basically. Now you're asked to find the number, so you got to find in this case two numbers. All right. So let's look at that first statement though. This one right here. Let's look at this first. So remember, is means equal. So one number is four more than three times another number. So let's think about this word right here, another number. So let x equal that number. So let x equal the number. And then this number, that second number, let's call it the first number if you want to. First number. Then the second number is four more. Remember, four more means to add, and then times means multiplication, right? So four more, so 4 plus 3 times this number here, x. So this will be 4 plus 3x. All right, so that first statement, we got these two expressions from that first statement. So this number right here, we're going to call it x, and this number here is 4 more than 3 times x. All right, now we're going to use that second statement for our equation. So you're told that the sum of these two numbers, so the first number plus the second number, has to equal 88, right? So we have x plus 4x plus 3. Oops, sorry. 4 plus 3x has to equal 88. So I messed up here. Combine like terms. I get x plus 3x is 4x. I get 4x plus 4 equals 88. And so I have this linear equation. I'm going to subtract 4 from both sides. So I get 4x equal 84. Divide both sides by 4. I get x to be 21. All right. Now, remember, make sure you answer the question. So don't stop there. Go back and make sure you answer the questions. The question is, though, what are the numbers? So remember, there are two numbers. So let's just go right here for right now. So remember, this is 21. That represents x. So that means then that my first number is 21. Then my second number is 4 plus 3 times 21, right? 4 plus 3 times 21. So that's order of operations. You're going to multiply first. So 3 times 21 is 63. So I get 4 plus 63, which gives us 67. So you're going to answer the question. So you're going to say the two numbers are 21 and 67. Okay? And so if you add those up, though, 21 plus 67 is 88, isn't it? All right. So you could use that idea for part 6. Does that make any sense? All right. And then you could also do this. If you multiply this by 3, multiply this by 3. 3 times 21 is 63. Add 4, you get 67. All right. Okay. All right. All right. Number 2. If 6 times a number is decreased by 6, the result is the same as when 3 times a number is increased by 12. You want to find the number. Now, the difference between 2 and 1 is that number 2, you're looking at two numbers, and number 1, you're just looking at one. So all these words, that number represents that same number. So just let x equal the number. Let x equal the number. Now, let's look at that first statement. 6 times that number is decreased by 12. So remember, decreased means to subtract. Okay, keep that in mind. The result, when you see that word result, that means equal, right? That means equal. 3 times a number is increase. Remember, increase means to add. All right, so let's do that first statement. So we're going to write our equation. So that first statement says 6 times that number is decreased by 12. So 6x minus 12. The result is the same as when 3 times the number is increased by 12. So I'm going to say 3 times x, and I'm going to say add 12. So that's your equation. Okay? And I put 12 here. I meant to put what? 6 decreased by 6. Okay? So 6 times the number decreased by 6 is the same as 3 times the number increased by 12. Okay, so let's go ahead and solve this linear equation. So we'll go ahead and subtract 3x from both sides. So I get 3x minus 6 equals, that's 0, 12. Add 6 to both sides. I get 3x equal 18. Divide both sides by 3. I get x to be 6. All right, and then that's your number. So remember, x represents the number. So the number is 6. Okay? All right. Number 3. Now, the difference between 2 and 3, they look very similar. The difference, though, is this right here, 6 less than, 16 less than. So we got to talk about that, what that means, less than. So don't confuse this subtraction. It does involve subtraction, less than. Don't confuse that, though, with the way you wrote decrease. Those are two different, you write those two different ways. This is written differently than this. So see, when you said decrease by 6, you just said minus 6, right? All right, so be careful when you do this one. So again, when 6 times a number is increased by 11, the result is 16 less than 9 times the number. You want to find the number. So again, let's go ahead and let x equal that number. So let x equal the number. Now let's write our expression. The expression on the left side. So 6 times a number is increased by 11. So that means 6x plus 11. So that part's easy. The result is, so that's equal. Now be careful here, 16 less than. So when you think about 16 less than a number, you're going to write it this way. So you got to be careful with the word less than. All right. So if I say 9 less than 10, 9 less than 10, that means 10 minus 9. That's what that means. Okay? So you got to be careful. It does not mean 9 minus 10, because 10 minus 9 is 1. 9 minus 10 is negative 1. So when you see the word less than, when you see the word 9 less than, always put that subtraction in the back. So remember, subtraction is not commutative. The order in which you subtract does matter. The order in which you subtract does matter. So for this statement here where it says 16 less than 9 times a number, you can do the 9 times a number first. So that's 9x, and then you can subtract 16. Okay? So don't write 16 minus 9x. That's not correct. So it's 9x minus 16. Subtraction is not commutative. The order does matter. All right, so when you see the word less than, always put it at the end. Okay, now that's the equation. Let's go ahead and solve this linear equation. I'm going to go ahead and subtract 6x from both sides. Combine like terms, I get 11 equals 9x minus 6x is 3x minus 16. Add 16 to both sides. 16 plus 11 is 27 equal 3x. Divide both sides by 3. I get x to be 9. Okay? And so that's what you want to find, and so that's your number. So the number is 9. Okay? All right, so that's number 3. Let's look at number 4. All right, in number 4, we have the sum of two numbers is 57. The larger of the two numbers is 9 less, so here's that word less than again, less than twice the smaller. Find the two numbers. All right, so this time I'm dealing with two numbers, and they're using the words larger and smaller. So let's go ahead and use those words as well. So smaller number, larger number. Okay? Now, to write the expressions, before you write your equation, let's write our expressions. To write the expressions, we're going to use this fact right here. So you're told that when you add those two numbers, you're going to get 57. All right, so let's think about that. Let's think about what that means. So if I add two numbers whose sum is 57. So for example, if my smaller number is, let's say, 10, then what's my larger number? They have to add up to 57. So that has to be what, 47? So how'd you get 47? You said 57 minus 10, didn't you? Right? So if my smaller number, let's say, is 20, then what's my larger number? Was that 37? And how'd you get 37? You said 57 minus 20. So this is here, this is here. So here's the thing then. All right, suppose my, and let me go ahead and raise this down, bring this down. So let's suppose this is x. Then what's this then? Use that same pattern. So if this is 10, you said 57 minus 10. If this is 20, you said 57 minus 20. Well, if this is x, you'd say what? 57 minus x. And when you add them up, just like here, when you add these up, what's x and a negative x? 0, and you get what? 57. So that's what you're going to do. You're going to say let x be the smaller, and the larger will be 57 minus x. Okay? All right. So that's how you wrote the expressions from this first statement. Now you write the equation from these two, because look at what it says. The larger of the two numbers is 9 less than the smaller. So remember, is here is going to be our equal sign. So let's look at the sentence again. The larger of the two numbers. So which one's the larger? 57 minus x. So 57 minus x is 9 less than, so remember you're going to put that at the end, 9 less than twice the smaller. So if this is smaller, then how do you represent twice the smaller? 2x. And there's your equation. That's the equation. All right, so let's go ahead and add x to both sides. I get 57 equals 3x minus 9. Adding 9 to both sides, 57 plus 9 is, what's that, 66? Equal, that's 0, 3x. Divide both sides by 3. I get x to be 22. All right, so x is 22. And so remember, make sure you answer the question. You're trying to find two numbers now. So if x is 22, then so that's your smaller number. So my larger number then will be 57 minus 22, right? Which is going to be 35. So the two numbers are 22 and 35. Okay? All right, now someone may ask, well, could you have let the larger number be x? Yes, you could have. So watch. You'd still get the same answer. You'll still get 22 and 35 as the numbers, but suppose this time, I just want to show you something. Suppose this time that you said, I'm going to let the larger number be x. All right, so if the larger number is x instead, see, we let x be the smaller number here. So if we let x be the larger number, then the smaller number would be 57 minus x in this case. And when you add them up, you get 57. But the equation, see how this equation, we did this one? We said the larger of the two numbers, so that was this one, is 9 less than twice the smaller. So this time it's going to look different though. So watch. So remember, the larger, which is x, is 9 less than twice the smaller. Now you got to be careful here. So the smaller here is a binomial. It's more than one term, so you got to put that in parentheses. So twice the smaller. So that's what it looks like. 2 times 57 minus x. So that's the equation here. So notice that equation looks different than this one. Okay, distributing. I get x equals, and then 2 times 57 is going to give us 114 minus 2x minus 9. Combining like terms, you get x equal 114 minus 9 is 105 minus 2x. Adding 2x to both sides, I get x plus 2x is 3x equal 105. Dividing both sides by 3, I get x to be 35. So notice this time I got x to be 35. Over here I had x to be 22. But remember, x here, this x here represents the larger number. So this time I get 35 for x, and then the smaller number is going to be 57 minus 35, which is 22. So notice I get the same answer, right? 2235, 2235. It's just that I let x be a different expression here. X stood for something differently here than it did here. But you still get the same answer. You still say the two numbers are 22 and 35. You still say that. Okay? All right. So that was number 4. All right, now let's get to number 5. So now this time we're going to start talking about consecutive integers. Consecutive integers. So let's kind of review something about consecutive integers. Consecutive integers. So for example, if I have the number, let's say 10, then the next consecutive integer is 11. Then the next consecutive integer is 12. Then the next consecutive integer is 13, right? So those are consecutive integers. And I want you to notice something. When I go from 10 to 11, notice all I do each time is keep adding 1, don't I? Keep adding 1. 12 plus 1 is 13. 13 plus 1 is 14, and so on. Okay? So that's what I mean by consecutive integers. All right? So if I have the number, let's say 22, then the next consecutive integer is 23. 22 plus 1 is 23. Okay? All right. So we're going to use that idea with this one. So you're going to find two consecutive integers whose sum is 23. So when you think about that equation, you're thinking about, well, the first integer plus the second integer has to equal 123, right? That's what you're thinking about. But we got to have some expressions here. And so what we're going to do now is going to say, well, I'm going to let the first integer equal x. So the first integer, that's first right here, first integer. Then the second consecutive integer. So let's think about this. So if my first integer is 20, let's say, then the next one's 21, right? So I'm going to add 1. Well, if my first one's x, then what's the next one? X plus what? X plus 1, right? You added 1. So remember, 21 is 20 plus 1. So 20, 21. And you get 21 by saying 20 plus 1. You get the next one by saying x plus 1. All right? So the next second consecutive integer will be x plus 1. Kind of makes sense, because think about it. If x is 5, then what's 5 plus 1? 6. If x is, let's say, 40, then what's the next one? 41. 40 plus 1 is 41. All right? And now we're going to take these expressions, put it here. So my first integer is x. My second integer is x plus 1, and that equals 123. And there's your equation. That's the equation. Combine like terms, I get x plus x is 2x. I get 2x plus 1 equals 123. Subtract 1 from both sides. I get 2x equal 122. Divide both sides by 2. I get x to be 61. Okay? So, make sure you answer the question. You want to find two consecutive integers. So let's go here. So if my first one is x, which is what I just found, then my next one is 61 plus 1, right? So that's 62. So the answer, you're going to say the two consecutive integers are 61 and 62. All right, so that's number 5. Number 6. Now the difference between 5 and 6, the idea is the same, except you have a negative 97. So don't let that throw you off. Remember, integers can be positive, negative, 0. Integers can be negative, positive, or 0. Okay, so let first integer, let's say x, then a second integer, consecutive, right? So make sure you read it carefully. Second integer is x, going to be x plus 1, right? So you're told that the sum, though, is negative 97. So the first integer plus the second integer has to equal negative 97. So you can say x plus 1 has to equal negative 97. Combine like terms, x plus x is 2x. I get 2x plus 1 equals negative 97. Subtract 1 from both sides. I get 2x equals negative 98. A negative 97 and a negative 91 is a negative 98. Divide both sides by 2. I get x to be a negative 49. All right, now let's answer the question. So you want to find those two integers. So my first one's negative 49, right? My second one, now be careful, you're dealing with negative numbers here. Negative 49 plus 1 is a negative 48. All right, so the two consecutive integers are negative 49 and negative 48. All right, and if you add them up, remember, does that make sense? Remember step 6, does that make any sense? Well, they are consecutive, aren't they? Negative 49, negative 48 are consecutive integers. And when I add them up, I do get negative 97. All right, now let's get number 7. So, number 7. This time, now be careful, always read carefully, you're dealing with two consecutive even integers. Even integers. So, we talked about consecutive integers. Now we need to talk about consecutive even integers, right? So let's think about that for a moment. Put that here. Consecutive even integers. So let's talk about consecutive even integers. Okay, so let's say I had the number, and we're dealing with even. So let's say I had the number 10. What's the next consecutive even integer? 12, right? And what's the next one after that? 14. Next one after that? 16, and so on. I want you to know, just like we did this, so to go from 10 to 12, what did I add? 2. 10, so 12 we get 10 plus 2. And then go from 12 to 14, I added 2 again. To go from 14 to 16, I added 2, didn't I? Okay? So when I'm dealing with consecutive integers, you keep adding 1. 10 plus 11, 11 plus 12, 10 plus 1, 11 plus 1, 12 plus 1, and so on. Okay? Now, one more thing I got to ask you. If I go from 10 to 14, what did I add? So I go from 10 to 14, what did I add? 10 plus what's 14? 4, right? And so see, 2 plus 2 is this 4 here. Okay, so we're going to use that idea in a little while. Okay, now let's look at number 7. Find two consecutive even integers, so even, whose sum is 54. So let's call this in the first even integer. Let's call it x. And then the second consecutive even integer. Now be careful, don't say x plus 1 like you did here. You got to remember, to go to that next even integer, I didn't add 1, I added what? 2. So x plus 2. Okay? All right, so those are 2. So those are you're looking for 2, so those are your two consecutive even integers, x plus 2. You're told, though, that the sum is 54. So the first plus the second has to equal 54. So x plus 2 has to equal 54. All right, so there's your equation. Combine like terms, I get 2x plus 2 equals 54. Subtract 2 from both sides, I get 2x equals 52. Divide both sides by 2, I get x to be, and in this case is what, 26? So there's your, remember step 6? Check to make sure it makes sense. Well, that better be even, right? Because that's what I called it. And my x was an even integer. Then my next consecutive even integer is going to be 26 plus 2, which is 28. And so those are my two consecutive even integers. So the two consecutive even integers are 26 and 28. All right, so let's see if that makes sense. So they are consecutive, right? And when I add them up, I do get 54. All right, so that's number 7. Okay, let's get number 8. Now, number 8, you got to be careful with the statement that we're about to look at. This time you're looking at consecutive odd. So let's talk about consecutive odd for a moment. I'm going to put it right on the consecutive even. So consecutive odd. Okay, so I'm dealing with odd integers, right? Consecutive odd integers. So let's say the first one is 11. What's the next one? 13. What's the next consecutive odd integer? 15. The next one? 17, and so on. So in every case, though, notice 11 plus what is 13? Plus 2. 13 plus what's 15? Plus 2. 15 plus what's 17? Plus 2. So isn't it the same idea as with consecutive even? So consecutive even integers and consecutive odd integers, you're going to add 2 each time as well. All right? Because you remember you're dealing with consecutive, in this case even, so my first one better be even. To get the next even, you add 2. First one better be odd. To add the next one, you better add 2. Okay? All right. Now, be careful in this case, though. It says 3. You want to find 3 consecutive odd integers. So let's talk about that. So let's say the first odd integer is x. The second consecutive odd integer is going to be what? So let's think about this. So if my first one is 11, what's my second one? 13. So you said 11 plus what? 2. So you're going to say x plus what? 2. The third consecutive odd integer, now be careful, don't say x plus 2 again. Okay? You're looking at the third one. So you're looking at 15 in this case, let's say. So to go from 11 to 15, I add what? 4. 2 plus 2 is 4. So the next one you keep adding 2, right? Plus 2, plus 2, plus 2. So if I add 2 to the previous one, what's 2 plus 2? 4. So x plus 4. So those are your 3 consecutive odd integers. And make things easy on yourself. Think about it. Ask yourself if what I have is correct. So my first one, let's say we're dealing with odd, right? So my first one is 15. Then what's 15 plus 2? 17. And then what's 15 plus 4? 19. And are all those consecutive odd? Yes. 15, 17, 19. Okay, so my expressions are correct. Now you're told that the sum of those 3 is 75. So that means the first plus the second plus the third has to equal 75. That's what that means. So x plus 2 plus x plus 4 has to equal 75. All right? So combine like terms, x, and x, that's 3x. 2 and 4 is 6, equals 75. Right? Subtract 6 from both sides. I get 3x equals 75 minus 6 is going to be, what's that, 69? Divide both sides by 3. I got x to be 23, right? 23. All right, so that's what x is. So make sure you answer the question. You want to find 3 consecutive integers, odd integers. So x is 23. That means the next odd integer is 23 plus 2, which is 25, right? And the next one is 23 plus 4, which is 27. So 23, 25, and 27. And when I add them up, I do get 75. So the 3 consecutive odd integers are 23, 25, and 27. All right, so that was number 8. Okay, number 9. Okay, so you want to, same idea. You want to find 3 consecutive odd integers. So our expression is going to be the same as these. That's not going to change. It's just that the equation is going to change because it's stated differently. All right, so you want to find the integers. You want to find those 3 consecutive odd integers. You're dealing with odd integers and consecutive. So first odd integer, second consecutive odd integer, third consecutive odd integer. So my first is x, then how to get the second odd integer? X plus 2. How to get the third one? You add 2 to the previous one, so x plus 4, right? Okay. Now, be careful. You're told that the sum, so you're adding, the sum of the first and third is 70. So it's not all 3, it's just the first and the third is 70. So my first is x, and my third is x plus 4. And that's 70. So there's your equation. So the sum of the first and the third is 70. Combine like terms, you get 2x plus 4 equals 70. Subtract 4 from both sides, you get 2x equal 66. Divide both sides by 2. I get x to be 33. And the last step where it says check your solutions, make sure it makes sense. Well, x was my first odd integer and I did get 33. So far it kind of makes sense because it is odd. My next one, remember you want to find the integers, all three. So my next one is 33 plus 2, which is 35. And my next one is 33 plus 4, which is 37. And then let's check to make sure that the first and the third, so duh, is 33 and 37 equal to 70? And the answer is yes. All right, so the three consecutive odd integers are 33, 35, and 37. All right, so that was number 9. Okay, number 10. Let's see what we have here. So this time we have three consecutive integers such that 3 times the smallest is 14 more than the largest, and you want to find the integers. Okay, so let's call those first, second, third, and you're dealing with consecutive integers, not even, not odd consecutives, just consecutive integers. So first integer, second consecutive integer, third consecutive integer. So my first one's x, then what's the next one? X plus 1. Then the next one after that, you add 1 to the previous one. So 1 plus 1 is 2. So that's how you represent 3 consecutive integers. Now, be careful. You're told that 3 times the smallest, so let's say this is my smallest here, and this is going to be the largest. 3 times the smallest is 14 more. Remember, more than means to add the largest. So 3 times the smallest, so let's get that first. So if x is my smallest, then 3 times the smallest is 3x. Is means equal, right? Is means equal. 14 more, so 14 plus the largest, and the largest is x plus 2. And there's your equation. 3 times the smallest is 14 more than the largest, and the largest is x plus 2. Okay, combine like terms, I get 3x equal 14 plus 2 is 16, so I get 16 plus x. Subtract x from both sides, I get 2x equal 16, right? Divide both sides by 2, I get x to be 8. Okay, now you want to find the integers, right? All three. So x is 8, so that's my smallest. The next one is 9, right? 8 plus 1 is 9. And the next one is 8 plus 2 is 10. So the 3 consecutive integers are 8, 9, and 10. Okay, not that difficult, fairly easy to deal with. Okay, so let's look at the next one. 3 consecutive odd integers again, such that the sum of the first and the second is 31 less than, be careful with the word less than, 3 times the third. So you're dealing with consecutive odd integers. So first odd integer, second consecutive odd integer, third consecutive odd integer. So if the first one is x, then what's the next one? Odd, consecutive odd. So if the first one is 5, the next one has to be 7, right? So you can say 5 plus 2. The next one will be 5 plus 4. Okay? So those are your consecutive odd integers. Now, here's the equation. The sum, so you're going to add the first and the second. First and the second. So x plus 2 is 31 less than, so remember how we dealt with that less than, minus 31 at the end. So remember, subtraction is not commutative. You got to be careful when you subtract. 3 times the third. Now be careful, you got to put 3 times the third, so there'll be 3 in parentheses, and the third is x plus 4, so 3 times x plus 4 like this. Okay? So the sum of the first and the second, is 31 less than 3 times the third. Okay? All right, so there's your equation. We're going to go ahead and distribute, and let's combine like terms here. X plus x is 2x. I got 2x plus 2 equal 3x plus 12 minus 31. Combine like terms, 12 minus 31 is a negative 19. I got 2x plus 2 equals 3x minus 19. subtract 2x from both sides, combine like terms, I get 2 equals x minus 19, add 19 to both sides, I get x to be, and then 19 plus 2 is 21. Okay, so we're going to find the integers. So my first one's 21, my next one is 23, right? 21 plus 2 is 23, and then 21 plus 4 is 25. So the three consecutive odd integers are 21, 23, and 25. Okay? All right. Now, let's kind of see if it makes any sense. So they are consecutive odd. I did find that. And then you're told that when you add the first and the third, I'm sorry, the first and the second, so kind of meaning this. Let me go ahead and write that here. So this says that when you add the first and the second, so 21 plus 23, that is, was that 44? So when you add the first and the second, then that sum here is 31 less than 3 times the third. So 3 times 25 is 75. And then it's going to be 31 less than that. If I subtract 31, I get 44, and that's what that said. Okay, so it does make sense. So in terms of that step 6 right here, this is what you would have done. So you use this information here to make sure in actual numbers that it does make sense. All right, that was number 11. Okay, now number 12. Number 12. So you want to find three consecutive integers such that should be that right there, such that the sum of the smallest and 3 times the second is 38 more than twice the third. Okay, so a lot of information here, a lot of words, but don't let that throw you off. So let's first of all deal with the fact that we're dealing with three consecutive even integers. So first, even integer, let's say that's x. Second, consecutive even integer is going to be x plus 2. Third, consecutive even integer is going to be x plus 4. And we're going to use the rest of this for our equation. So it says such that the sum of the smallest, so x would be the smallest, so the sum of the smallest x plus 3 times the second, so 3 times this. Okay, so let's look at that again. The sum, so there's our sum here, the sum of the smallest and the second, 3 times the second, is, so that's equal, is means equal, right? 38 more than twice the third. So there's your third. So twice the third. So there's our equation. So the sum of the first and 3 times the second is 38 more than twice the third. Okay? And you want to find those three integers. Distributing in both cases, I get x plus 3x plus 6 equals 38 plus 2x plus 8. Okay, you remember you got to multiply first before you add, so don't say 40 here. Combine like terms, I get x plus 3x is 4x. I got 4x plus 6 equal 38 plus 8 is going to be 46 plus 2x, right? Subtract 2x from both sides. I get 4x minus 2x is 2x plus 6 equal 46. Subtract 6 from both sides, get 2x equal 40. Divide by 2, I get x to be 20. All right, so far it makes sense because I am getting an even integer. So my first is 20. My second is 20 plus 2, which is 22. And my third is 20 plus 4, which is 24. All right, so let's kind of see if what I have actually makes sense. So that's step number 6, I guess. Yeah, step number 6. So this is what you're told. The sum of the smallest and 3 times the second. So the smallest is 20. And then 3 times the second, which is 22. So let's see what that is. So 3 times 22 is going to be 66. And then 20 plus 66 is 86, right? Okay. And they're saying that this number is going to be 38 more than twice the third. So let's look at that. So let's see if this number is 38 more than twice the third. Then the third's 24. So 2 times 24 is 48, and then 48 plus 38, use your calculator if you have to. 48 plus, was that 38? Is 86, right? Right, and they are equal, right? Those are equal. So what we have is correct. Okay, and then finally, number 13. So I think you should have enough examples to get you to understand the idea with the number and consecutive integer problems. So let's go to number 13. Two consecutive integers are such that 3 times the larger exceeds twice the smaller by 34. All right, so you're dealing with consecutive integers. Um, and then I guess the statement should have been find the integers. Find the two integers. Okay, so find the two integers. All right, so first integer is going to be x. Second consecutive integer will be x plus 1, right? Okay. All right, so this is what it says. 3 times the larger. 3 times the larger. So here's the larger right here. That's the smaller, that's the larger. So 3 times the larger exceeds, so we're going to say exceeds means larger, I guess, is more than. So 3 times the larger exceeds, so that's at 34. So it means it's increasing by 34. That's what that means. So is 34 more than twice the smaller. So the smaller is x, you can say 2x plus 34. So that exceeds means you're going to be adding 34. Okay? So 3 times the larger, so 3 times the larger is 34 more than twice the smaller. Okay? So there's the equation. Distributing, I get 3x plus 3 equals 2x plus 34. Subtract 2x from both sides. 3x minus 2x is x, plus 3 equals, and this is going to be 34. Subtract 3 from both sides. I get x to be 31. So my first integer is 31, and my second is 32. Okay? All right. And so the numbers are 31 and 32. Okay? All right. Now, let's kind of do that step 6. Let's kind of check this to see if it makes sense. So 3 times the larger. So if I take 3 times 32, 3 times 32, which gives us what? That's going to be 62. Sorry, 6. That gives us 93. So that's 96, right? Okay, 96. All right. So they're saying that this number is going to be twice the smaller plus 34. So twice the smaller. So the smaller is 31. So twice the 31 plus 34. 2 times 31 is 62. 62 plus 34 does give us 96. Okay? All right. So that is our problems on the objective. Let me just go back real quick. So it's quite a few, but I think I gave you enough to handle this topic right here. Translate verbal expressions into mathematical expressions, and we're dealing with numbers and consecutive integers.